Hey, Aurora here with Supercharged Math. Are your kids struggling with fractions and you know they could be doing so much better? I'm actually about to take you into a class that I just recently gave where we took kids who had never seen fractions before, and in 20 minutes the kids were able to add, subtract, and multiply those fractions, reduce those fractions, and really had a solid understanding of what fractions were, and it didn't take that much effort. So let's go into the class and get started. If you like this and you want more, you want to go to my website, superchargedmath.com, to learn more about how your students can be part of my classes that I have for grades 4th all the way through 8th. All right, let's dive into that class right now. So fractions, and do you see where it says fractions at the very top? Okay, so fractions are part of a whole. I want you to write the word whole in here. Okay, fractions are part of a whole. Okay, what does that mean? So we have a fraction here. We have one number, a line, and another number. The one on the bottom, this is how many make a whole. So if I have 4 of them, then I have a whole unit. And it could be a whole of anything, right? It could be a batch of muffins. It could be how many cakes fit into your car. That would be a whole unit, right? 3 is how many we have. How many we have. Okay, I am doing this with Sharpie, not pencil, so it will show up better on the video. You should be using pencil when you do your notes and when you do math in general. Always a good idea. Okay, all right, so if I'm saying 4 makes a whole, look at this, 1, 2, 3, 4. So this unit, this circle with the little crosshairs in it, that is a whole. If I say I've got 3/4 of a circle, what does that mean? That means I've divided my circle into 4 parts, and I've got 1, 2, 3. Okay, so 3 is shaded out of 4. Does it have to be a circle or a pizza? No, it doesn't. It could be one of these. It could be a candy bar. You guys like candy bars? So imagine you've got one and you slice it into 4. The important part here is that the size of the divisions is equal for each one. You can't have a giant piece and a tiny piece, right? Imagine doing that with a kid. Yeah, they're not gonna be too happy, right? So all of your divisions have to be the same shape and same size. They have to have the same amount of stuff. So I can take my candy bar and split it into 4s. 3/4 is gonna be 1, 2, and 3. Okay, I can shade, this is how many we have. I ate 3 out of how many? How many possible is on the bottom. That's how many make a whole. 1, 2, 3, 4. This makes 1 candy bar. I split it into 4 equal pieces, and I eat 3 of them. Okay, so I ate 3/4, and now I'm not feeling so good. How are we doing so far? Okay, so let's take this a little bit further. Do you see the pictures on the bottom here? Okay, so let's take a look. We're gonna color our own, but before you start doing that, because your fractions will be different than mine, I want you to go like this. Can you put a line under each one? Can you go like this? Okay, so what I want you to do is this. On the bottom, remember, this is how many make a whole. I want you to count them up. This one is 1, 2. That's the bottom number, also known as your denominator, okay? Denominator is like a dungeon. It's on the bottom, okay? So there's 2 possible. Now, what about this one? There's 4 possible, right? 1, 2, 3, 4, just like we had up here, right? 4 possible, so you're gonna write that at the bottom, okay? What about this one? How many are in here? So when we get to these, sometimes it's a little hard to count them, so just start with a dot. 1, 2, 3, just put dots in it. See, 6? Okay, I have 6, so that's 6 possible. So 6 slices make 1 whole pizza, right? All right, what about this one? How many are in here? Can you count them with me? 1, 2, 3, 4. Oh, I'm only counting 4, and notice that's a half. If I take 4 twice, 5, 6, 7, 8, I get 8, right? So there are 8 slices that make a whole unit. So this here is just 1/8. So this is in eighths. This is in sixths. It's so the number 6 with a TH after it. How many are in here? There's a lot to count. So start with the dot and then go all the way around and tell me, how many do you have? Just shout it out when you know it. Okay? 10. There's more than 10, Amanda. So what do you have? Yeah, 12. That's right. There are 12 here. So 12 make a whole. All right. So now I want you to shade in as many as you want. So for this one, let's just shade in 1 because otherwise we've got the whole. There we go. So that's 1/2. All right. So shade in other amounts. Go ahead and do it. I'll give you just a second. And they don't have to be side by side. They can be, so, okay? And however many you shade in goes on the top. Do you see that? Okay, so go ahead and shade a few of them in. You don't have to do them all. Just shade in the ones that you want. Okay, doesn't have to be the same as mine. You just make your own. Make your own fractions. All right, so we got 1, 2. I'm only going to do 3 on this one. How many are you doing? Okay, maybe I'll use purple again. 1, 2, 3, 4, 5. Okay. All right, so you want something that looks like mine in that you've shaded it, and the number the number of sections you shaded is the same number that's on top. So do you have that? Okay, so go ahead and finish that up. Yeah, don't spend all day on this. We got a lot to do. Okay, I want you to notice something. All right, let's look at the 8 since I had highlighted that one. What would happen if you had gone in here and shaded all of them? Imagine I did all of them. Okay, I'm going to write that one down here. Okay, so the original was 3, but now I'm going to do a different one. Okay, 8 is still on the bottom. That doesn't change. But what's on the top? Well, I shaded all of them, so that I got to put an 8 on the top. Anytime you have a number over itself, that means 1, and that 1 means 1 unit. So if you order a pizza and you eat, and it had 8 slices, and you eat all 8, you could say, I ate 1 pizza. If you made a dozen muffins and you ate 12 of them, 12 is a dozen, you could say, oh, I ate the whole thing. I ate 1. Okay, put a smile on your face if that kind of makes sense. All right, now watch this. If I have any number over itself and it's the same number, it's always going to be 1. 3 over 3 is 1. 1,000,000 over 1,000,000 is 1. So anytime I have a number over itself, it's always 1. Doesn't matter how big it is. Here, I'll put 1,000,000. It's always going to be 1 because why? This is the number of divisions on the bottom. This is how many make a whole. If you happen to have that many, now you have a whole. All right, so give me a smile so I know that this is working. Put a little smile on your face, yeah? Okay, so that is page number, this was page 3. This is the first page we're doing. Okay, so flip the page. I want you to take a look. Now we're on page number 4, okay? All right, so multiplying fractions. How do we multiply a fraction? Okay, so the easy way to do it is like this. I want you to write this with me. Okay, so let's just skip the sample. I'm actually going to show you how to do it. Write 2 over 5. So there's 5 divisions, and I ate 2 of them. Okay, or you ate 2 of them, okay? All right, and then I want you to write another one really close by. Can you do that for me? So write 2 over 5, and then 1 over 3. Okay, great. Now, can you put a little X between them? So this is our multiply sign, right? Now, I want you to take your hand and go like this. Take your hand and put it over that. So you only see 2 times 1. You tell me, what is 2 times 1 equal to? 2 times 1 is 2. Yeah, so you write that on top. And then you put the line. And now you take your hand and you move it and you go like this. What is 5 times 3? 5 times 3 is, that's right, 3 times 5 is the same. Good, good. Yeah, it's 15. And that's the answer. So anytime you multiplying fractions is easy. But you got to use the hand thing. So let's do another one. How about 3/4 times 2/3? Okay, so grab your hand, put it on the bottom. What is 3 times 2? 3 times 2 is 6. Now move your hand. What is 4 times 3? 4 times 3 is 12. Excellent. I'm getting this. Oh, I'm so glad, Eileen. Good job. Okay, let's do another one so you're comfortable. Okay. How about 6? Oh, you know what? Oh, wait. Hang on. You know how you erase things when you're doing math with a Sharpie? You put a sticker on it. There we go. All right. So I wanted to take a look at this a little bit closer. Okay. So let's say, for example, I have this here. Can you draw a circle next to it? And then put a big line through it and then another line like that. Can you do that for me? Okay, great. Now what I want you to do, this is going to take a little bit more work. Watch me first. I want you to draw 2 more lines. Can you do that? And then draw 2 more. Okay, it's okay if they're not perfect. And then draw 2 more. And then draw 2 more. Okay, got it? Okay. There are now 12. This is a circle that we had divided into 12 parts, just like we had here, right? So this is 12, and that's what's on the bottom. Can you color in 6 for me? Get your pencil out. Color in 6. It could be any 6 that you want. You can alternate. You could do it like this. Okay. I'm going to do it like this because I want to show you something really cool. Okay, so watch this. Let's work with this number, 6 over 12. Here, I'll move this up so you can just see that. Okay, so 6 over 12 is, what is 6? 6 is equal to 2 times 3. Would you agree? Okay. And, oh, that's a 12. And 12 is equal to 4 times 3. Is that right? Okay, take a look at what I have here. Look at this. Look at this. 3 over 3. Now, where have we seen that before? Where have we seen that before? I'll give you a hint. We did it on this page, kind of around here. What do you notice? What do you notice? Yeah, it equals 1, doesn't it? Can you tell me right now, if that equals 1, then what do we do with it? What do you think we do with it? Okay, that's right. We put a 1 here instead of a 3 over 3. We can make that a 1. So you could just put your finger over it because 1 over 1, we could multiply numbers by 1 all day long and nobody really cares. All right, so what do I have? I now have 2 over 4. So this thing turns into a 1. 2 times 1 is 2. 4 times 1 is 4. Okay, so I have a 2 over 4. So even though this is a 6 over 12, I can break it down into parts and make it even smaller. So what have I done here? Draw another picture. Draw another picture. Give me another circle with the little X, with the plus in it, just like that, okay? All right, and then what else do we do? Well, now we've got 4 divisions, 1, 2, 3, 4, okay? And now we're gonna color in 2. All right, so color in 2 of them. And then what do you notice? Take a look at this shape right here. This is exactly the same shape as this. Do you see how 6 12s is equivalent to 2 4s? They're exactly the same fraction. Yeah, we just multiplied it by something to get the numbers to be different, but what it means is exactly the same. And I see students already reducing it even more. Yes, yes, you're already ahead of me. Okay, so if I have this one, so we have 2 over 4, right? 2 over 4. 2 is equal to 2 times 1, right? It's just 2. And then 4 is 2 times 2. Okay, do you see the form of 1? That's right. Where is the form of 1? Here, I'll use a highlighter this time. 2 over 2. Okay, this works because it's multiplied. If it was added, you couldn't do this trick. All right, but it's because it's multiplied. You see 2 over 2, so this is going to become a 1. Do you see how that's a 1? That's a whole unit. Okay, so what do I have? I am left with 1, and I'm left with a 2. And then here, last picture. Draw one more circle. You're going to get good at circles. But now, only put 1 line through it. What did we do? We just took a circle. We divided it in half. And do you notice how the shape is the same? Yes. This is how we scale fractions. We'll take a half. We'll multiply it top and bottom by the same number and we'll get different amounts of divisions. What are we doing? When I multiply 1/2 by 2 over 2, that's a form of 1, 2 over 2, I'm putting in 1 more division right here. I'm increasing the number of divisions when I'm multiplying this. So if I take 2 over 4 and I multiply the top and bottom by, say, 3 over 3, like we did here, now I'm going to get 2 times 3, which is 6, and 4 times 3, which is 12. This 3 simply means instead of 1 piece, there should be 3. Do you remember when we drew that up here? So we're increasing the number of divisions when we multiply top and bottom by the same number. This is a 1. We're multiplying it by 1. Right? 3 over 3 is a whole, that's a 1. But the way it breaks into what it does is it scales the fraction up so we can add things a lot easier. So how does that look so far? I'm going to pause here for a second and see if we've got questions. This is a big deal, what we're talking about right now. Yeah, adding more divisions. That's right, that's right. Good job, Sam. We are adding more divisions. That's right. Every time we multiply by some form of 1, 10 over 10, 3 over 3, 2 over 2, for 2 over 2, when what we're doing is we're saying instead of 1, we want 2 divisions. Okay, so we had 1, but if we multiply by 2 over 2, now we want 2 divisions because now there's 2 times 2, which is 4, which is going to be the whole. All right, so how are you feeling about this so far? Let me stop there here. I'll leave this up here. Oh, here, this shouldn't really be there. That's a 1/2. Okay, I'm gonna pause here for a second. How are you feeling about what we've been talking about? Pretty good? Okay, this is making sense. Oh, good, I'm so glad. Okay, so you wanna eat a round candy. Yes, I don't doubt that at all. All right, so can we move on to page number 5? Let's do page number 5, because we have to finish up our fractions so I can give you a math challenge. All right, adding and subtracting fractions. There's a sample at the top, okay? Here's what I want you to notice. Look at the 3. Here's the 3, here's the 3. Oh, and there's another 3. You mean I don't add the ones on the bottom? Nope. Anytime you add or subtract fractions, the 3 comes along for the ride. Whatever's in the bottom, they have to be the same, they have to match, and you don't add them, they just come along for the ride. You see, it wouldn't make sense to add because look, if you added the divisions, you would be changing the divisions. Where's my page? If I added the bottom numbers, it basically saying you're multiplying because you're changing the divisions. And that's not what we're doing here. We're simply saying, hey, I have a pizza. I ate 1/3 of a pizza. You ate 1/3 of a pizza. Together, we ate 2/3, right? So we're not changing how many slices there are in the box. Okay, it's different though for the top. The top tells you how many pieces got added, or if this is a subtraction sign, it got subtracted. Okay, so just make sure when you're adding fractions, the first thing is always to check the bottom. So let me give you a problem. 1/2 plus 2/2. Are the bottoms the same, yes or no? Yeah, denominators are the same. So bring it along for the ride. All right, now take a look at the top. The numerator is the top. 1 plus 2 is how much? 3. Is it okay for this to be bigger than that? The numerator to be bigger than the denominator? Absolutely. Yeah, the math can handle it. All right, here's another one. 1/4 plus 2/4. Okay, they're the same on the bottom, right? The denominator's the same. So let's bring it along for the ride. 1 plus 2 is 3. Excellent. Good, good, good. Okay. All right, what if I do, let's do a tricky one. Yeah, let's do a tricky one. Is that tricky? No. All right, so what do we have? The bottoms are the same. We'll bring it along for the ride. 2 plus 4 is 6. That's it, you're adding fractions. Should we do a subtraction one just for fun? All right, let's take 6 sevens and do something with it. 6/7 minus 3/7. What do I get? 6/7 minus 3/7. Any ideas? Okay, well, the 7s are the same, so let's bring them along for the ride. 6 minus 3 is, no, it's not 4. 6 minus 3 is 3. I get 3 7s. Okay. All right, so that's it for adding and subtracting. Do you think you can handle this? Yeah, when you look at the whole page, it may feel overwhelming, but if we just do it one step at a time, remember, you just check the bottoms and then bring it along, and then you do the top. Just add the top, and that's it. Yeah, but sometimes when you have a whole page full of problems, your brain might go, ah! Hang on a minute. Okay, so now let's take a look at page number 6. Page number 6, okay? And I'm gonna move the rest of this here so you can see it more clearly. Okay, adding and subtracting fractions. So this is where I think a lot of the confusion comes in with students. And honestly, when I teach mechanical engineering at Cal Poly, I can't, at the university, I teach engineering classes, or I have in the past. A lot of the time when the students make errors in their calculations, it's because of this. So let's take a look at what this is. All right, so what do you do if it doesn't match? What do you do if it doesn't match? Okay, so say I've got a 1/2 and I've got a 1/4. Okay, so you write this down. Okay, you write that down. If it doesn't match, we can't just start adding things. We can't say 2 plus 4 is 6. That doesn't make any sense. What we have to do is what's being done in this picture. We have to say, okay, we're going to scale this up just like we did on that earlier page by multiplying. And then we have to make the divisions the same. We have to make the divisions the same. Okay, so what does that look like? All right, so 2 and 4. So would it make sense here? Let's work on the half. If I have a half, I can multiply a half by a number, and the one number I can multiply it by that nobody cares about is 1. If I multiply 1/2 times 1, you and I, we don't really care. That equals a half. If it's a clever form of 1, we can get away with it because it's still 1 and nobody really cares. So what do? Remember how we multiply. You put your hand over the bottom. 1 times 2 is 2. and 2 times 2 is 4. We just scaled it up. Look, the bottoms are the same now. So instead of writing a half, this will now become 2 over 4 is the same as 1/2 because we multiplied it by 1. If we multiply it by another number, this won't be true. But because we multiply it by a clever form of 1, 2 over 2, okay, I'm also going to say plus 1/2, or 1/4, sorry, plus 1/4. All right, the bottoms are now the same. Bring it along for the ride. What is 2 plus 1? 2 plus 1 is 3. And there's your answer. Okay, so let's do this for a more complicated value, a more complicated problem, okay? So let's say, for example, we have, can you write this one down with me? 1 over 3 plus 1 over 2. Okay, see before, yeah, 2 is kind of related to 4, right? 2 times 2 gives you 4, but what if they're not? What if they're not related? Okay, if I have something like this, the easiest way to do it is to multiply by each other. So let me show you. So the 1/3, okay, we find a number that's common to both of them. So what is 3 times 2? 3 times 2 is 6. Great. So my common number is going to be 6. What do I have to multiply the 3 by to get 6? I multiplied it by 2, right? So that's going to be, so you write the 2 on the bottom and then you write the same number on the top. And now you do multiplication. 1 times 2 is 2. 3 times 2 is 6. We just scaled this up. 1/3 is the same as 2/6, right? Because we had 1/3 before. 1/3 looked like this. Here's our big slice of pizza, okay? What flavors would you put on your pizza? So I like basil and I like tomato. What about you? Chocolate chips? Did I seriously see somebody write chocolate chips? I'm coming to your house for pizza. Okay, so wait, get back to here. So what did we do? 1/3 is 3 is possible, 1, 2, 3, and then 1 is how many we have, right? 3 is how many make a whole. This is 1/3. When we multiply by 2 over 2, we're basically saying each one, instead of being one piece, it's now going to be 2. So we're going to divide each piece like that. Do you see how now there's 6? 1, 2, 3, 4, 5, 6 possible. Okay, 6 make a whole, but now there's 2 shaded, even though I didn't color in anything else. That's what we're doing here. Okay, so the 1/2, let's scale that one up. What do I multiply 2 by to get to 6? 2 times something makes 6. That's right, 3. So I'm going to write the 3 here, but then also put on the top. That way it'll be, we're just multiplying by 1, so we're not changing the problem. Okay. Now 1 times 3 is 3. 2 times 3 is 6. So what did we do? So originally it was a half. That's what a half looks like, right? You have half, I have half, everybody's happy because it's fair, right? But now because you multiplied by 3 over 3, that 3 is saying instead of 1 division, now there's 3, so you have to divide it by 3. You see that? How we made it 3 parts there? And you got to do the same on the other side. Okay? So now the numbers of divisions are the same, right? So I have 6 and 6, so I'm going to rewrite this number. 2 over 6 plus 3 over 6. So you basically add these two pictures together, and we get, the 6 comes along for the ride. 2 plus 3 is 5. Okay, and that's, so when we add those together, we get 5, 6. All right, I'm going to pause there and check in with you. Does that work the same for negative numbers? Good question. Yes, exactly the same. Only if we were to take 3, 6 minus 2, 6, we would just have 1, 6. So you just would subtract the tops. Good question. All right, so I'm going to pause here for a second. I'll leave that up so you can finish taking notes. And then I'm thinking it might be time for a little bit of an application piece. What do you think? How are we doing so far? It's easy when you draw pictures. Good. Butterscotch chips and Reese's on a pizza. Wow. Okay. So what do you think? Did that make sense? I know initially the class started a little slow. That's because slow is smooth and then smooth is fast. So we cover the fundamentals first. We take all the time we need to make sure those really make sense. And then we can start really speeding up. Now, This was an introductory fractions class. We didn't actually get to dividing fractions, which really isn't that difficult. The difficult part is adding and subtracting, and that's why we spent most of our time on that with the class, and sizing fractions and what does that look like, and drawing pictures, so it really makes sense to the students. Now, if you like this and you'd like more, I highly encourage you to try my math program. It's at superchargedmath.com. You can go there. There's a discount link included in that link that I just gave you, and you can learn more about this, so it really will make a big difference to you and your kids. If you have any questions, let me know. My personal email is aurora@superchargedscience.com, and I will see you in the next math class.